Okay, Surya.
Yes, sir.
We continue our little exploration of geometry. Especially algebra can assist us in geometry. How? Okay. The moral of the story is algebra can assist us in geometry. Example, here when I use the term algebra, remember that we mean linear space or vector space. We have already seen in our younger days that pre-calculus algebra could always assist us in coordinate geometry. Now the term geometry has been generalized to higher dimensions. Okay, so let us say, example, recall midpoint formula. From coordinate geometry. If P is the point with first coordinate x1, y1 and Q is the point with first coordinate x2, second coordinate y2, then the midpoint of line segment PQ is the point R equal to first coordinate x1 plus x2 upon 2, second coordinate y1 plus y2 upon 2. In algebraic form, now see the charm of the method. In algebraic form, R is equal to half P plus half Q equal to half of P plus Q.
Yes, sir.
Now, let's say our task is to prove a property of quadrilaterals. Let, you are very familiar with this, let ABCD be any 4 points and form a quadrilateral by joining them in that order. Then the midpoints of the 4 sides form a parallelogram, right? Form a parallelogram.
Yes, sir.
Now see how we can use this particular algebraic technique to get a quick, elegant solution. Proof. P equal to A plus B upon 2. Q is equal to B plus C upon 2. R is equal to C plus D upon 2. S equal to D plus A upon 2. Now here's the trick. To show that PQRS is a parallelogram, we know that in a parallelogram, diagonals what? Bisect each other.
Yeah.
In other words, this is a characterization of a parallelogram. If in a quadrilateral the diagonals bisect each other, it is a parallelogram. Right?
Yeah. Yes, sir.
Okay. Have you copied this?
Yes, sir.
Okay, just let me save it. So parallelograms bisect each other, meaning what? The midpoint of both the parallelograms is the same.
What did I?
Of the diagonals is the same. Yeah. So what do we do now?
C plus R upon 2.
Yeah, of course you know it. I know you know it. But I am just trying to be more pedantic here. Midpoint of PR. So that you get to is right? Midpoint of QS is Q plus S upon 2 equal to 1 by 4. I have skipped a little step in between. That is very obvious to you. Okay? And since these are equal, the theorem is proved. So I will show you the diagram, otherwise see it becomes quite complicated. There are two cases here. Without recourse to algebra, there are two cases here, and if we try to prove in a pure plane geometry way. Suppose this is A, B, C, D. Then consider the midpoints P, Q, R, S. This is case 1. Case 2. Can you... Huh?
I just saw this quadrilateral.
No. Here is a little surprise for you then.
Okay.
And I'm glad. I hope you enjoy the surprise. Let me draw it a little bit accurately so that you get the flavor of it.
Sorry. What? Obtuse angle quadrilateral. So there'll be. Wait. It's just a second. Concave quadrilateral. Sorry.
Draw it and show me. Come on. Draw it and show me on the camera.
Concave.
No. I think this case can be tackled. I'm not sure how.
I just solved it over here.
Yeah.
The same thing applies.
Same thing applies. Yeah, same thing applies. And I think the same geometric proof also might apply to this figure that you have shown. What I have is still a pleasant surprise for you. Hold on. Let me draw it accurately using the tools given in this MS Paint. So we say this is A, B, C, D, and these are the points P, Q. Let us say this chap is R here. I hope it is a good diagram. It is not a good diagram. P, Q, R. Sorry, this is S. This has to be S. The midpoint of AD is S. I'll correct myself. This is S. And the midpoint of CD is R. So if we draw this, I hope it is not looking, although
Yeah, so the same thing would apply.
yeah, the same algebraic proof would apply. That is right. And maybe we can have the third case that you have drawn.
No, that is elementary.
That is elementary. Okay. So what I wanted to emphasize, and do you agree with me, if we try to prove case 1 and case 2 by geometric ways, it is still much not so elegant as the algebraic way we learned just now. Especially for case 2.
Yes, sir.
You could try it in your head while going to sleep.
Yeah, I did.
Yeah, okay. Yeah. Okay. So now, okay. So this is one of the techniques that you will use in exercise 1 in some of the problems. Okay? Copied?
Yes, sir.
Okay. Now I want to take a slight detour and get you into some formal mode. Yesterday I told you that there are two kinds of properties of parallel of real numbers, algebraic and order. Right?
Yes, sir.
At one point I will remind you that I had in your last 2 years mentioned some of these properties and asked you to play some game with it or asked you to tinker with those. Now you can as a part of the homeworks, and it is really enjoyable. It will give you a firm grounding in formal analysis and topology.
Okay.
Step by step the abstraction will seem to be get more and more tangible. This is also the way to lay a firm ground in writing formal proofs in pure math. Okay? Okay. Having said that, let's, without further ado, we will go into this, and some examples will clarify the matter for you very well. Algebraic properties. We have the operations of addition, denoted by plus, and multiplication denoted by star or dot on R on the reals on R which extend the usual addition and multiplication of rational numbers. Surya, don't play drums. I am hearing some drums here. I know those are the drums of your victory. I know them very well. I am proud of it, but don't play it now.
Sorry, sir.
I can't concentrate with noise. Axiom A1 which you know is commutativity for all A, B, C in R. Axiom 2 A plus B equal to B plus A and AB equal to BA for all AB in reals. Axiom 3, A plus 0 equal to A and A dot 1 equal to A for all A belonging to reals. A4 given any A belonging to reals, there is A prime, A dash, A prime belonging to R such that A plus A dash equal to 0. Further, if A not equal to 0, then there is A star belonging to the reals such that A star equal to 1. Axiom 5, A into B plus C is equal to AB plus AC AB plus AC for all ABC belonging to reals.
Yes, sir.
So, all the familiar properties of algebra or even arithmetic that we take for granted have to be proven by these axioms. We will see one or two of them. Can I go to the next slide?
Yes, sir.
Familiar properties of algebra. To prove that A dot 0 equal to A for all A proof. 0 plus 0 equal to 0. Why? Since axiom, have a look at axiom 3. What did you write?
A plus 0 equals K.
So here a equal to 0.
Yes, sir.
Now a dot 0 equal to a times 0 plus 0 equal to a dot 0 plus a dot 0 by axiom
That is 5.
5. Good. So now it's simple. Now by axiom 4, have a look at axiom 4. There is a B prime belonging to R such that a dot 0 plus B prime equal to 0. Thus, what do we get? See, 0 equal to a dot 0 plus B star plus B star equal to a dot 0 plus a dot 0 plus B star equal to, are you understanding the
Yes, sir. Yeah.
repeated application of the axiom
Okay.
equal to a dot 0. This is also called proving mathematics or creating mathematics from scratch. From very sketch, from first principles. Copied?
Not yet.
So go through it for 2-3 minutes or 1 minute, because this is the flavor of everything in pure, a lot of things in pure math. And in fact, this is some of these similar problems I had asked you to prove during your one of your those.
I remember that.
Yeah. I think you had other priorities, so you had left it.
Yes, sir.
Yeah. I was just having my stuff to savings. Okay, child, come on. Next. So I will. There will be some homework related to using axioms to show familiar, by familiar I mean taken for granted properties of algebra. So in passing I will just mention, if a prime is a real number such that a plus a prime equal to 0, then a is additive inverse of a prime. Also, a prime is additive inverse of a. Notation, see, now you will enjoy a lot. The subtle game of math is here. Notation, a prime is minus z. You see, and slowly you will enjoy a lot, because you already have such a bent of mind. If a star is a real number such that a star equal to 1, here of course we say a not equal to 0, then a star is called reciprocal of a. Here again you enjoy notation. A star equal to is a raised to minus 1 or 1 over a.
Yes, sir.
So comment, a light comment. Using such basic stuff, we can come to a precise meaning of a plus b plus c, a times 1 over b, ab into c, a plus minus b, okay, or even the meaning of 2a squared, abc, a minus b. You see, all of them are related to some of the above.
Yes.
Okay, yeah. Now we will come to the meatier part, a little bit beginning of the scarier stuff, but it is still a light introduction, so not so scary. We come to the so-called order properties or topological properties. Of real numbers. Now there is a lot of formalism here, so be careful in what you write. Don't make any mistake. The set R contains a subset R plus called the set of all positive real numbers satisfying the following properties. Satisfying By the way, Gopal Iyer got a rank 5000 plus.
Okay. He spoke to you?
He wrote to me. He doesn't speak. He is very shy. There is no need to feel shy. 5000 out of 10 lakh students is a respectable rank. And anytime he can come up, he can blaze through in life. Anytime. Just some more work, proper guidance is required. Given any A belonging to R, exactly what happened to that Harshvardhan?
Sir, no idea.
And that Rohan?
No, I was not in touch with any of them.
It should be put the other way. They were not in touch with
They
you.
were not in touch with me.
Yeah. I was not like that. If I would find Chetan is so bright, I would always pester him with inane questions, even now. And so bright, so humble. Even Krishna is so bright, yet so humble. It would not, I don't know. Even now, I don't know something in my profession, I just ask anybody. I know it looks very dumb, but I don't mind. And there is a saying in Gujarati, Puchta puchta pandit thawai. Meaning, पूछते पूछते पंडित बन जाते हैं. See, it is one thing to ask, oh, solve this problem for me. And second thing to ask, oh, I have such a doubt. Could you please help me clarify? I am a little bit muddled. That means that you have already set the process of thinking on and you want some help. Call this O1.
Okay.
O1, order 1, order 2. If AB belong to R plus, then A plus B belong to R plus and AB belong to R plus. Given the existence of R plus, we can define an order relation on R as follows. For AB belonging to R, define A to be. If you have different color pens, it is still going to help you. All those simple things which I taught you.
Yeah, I need to. I don't have them right now.
Yeah. Keep them. If you think it will help you even now.
Yeah, it would. I just lost touch with it.
Yeah. Okay. Yeah. Okay, beta. Write AB, A less than B if B minus A belongs to R plus sometimes we write B greater than A in place of A less than B and say that B is greater than A. With this notation, it follows from the algebraic properties. It follows from the algebraic properties that R plus is the set of all x belonging to R reals such that x greater than 0. Shall I go to the next slide?
Yes, sir.
So moreover, the following properties are easy consequences of A1 to A5 and O1 O2. Number 1, given any AB belonging to the reals exactly one of the following statements is true. A less than B, A equal to B, B less than A. Number 2, if A, B, C are real numbers, with A less than B and B less than C, then A is less than C. Transitivity. Third, if A, B, C belong to reals with A less than B then A plus C is less than B plus C. Further, if C greater than 0, then AC is less than BC, whereas if C less than 0, then AC greater than BC. We end the lecture here. I will be sending you some homework in the night, which if you do, you will be thrilled. Okay?
Okay, sir.
Okay. Okay. Bye bye now.
Bye, sir.
Bye. Good night. Yeah.
So I'll be having a lecture. When will my next lecture be?
Tomorrow, same time.
Tomorrow. Okay. Good.
Okay then. Bye bye.
Bye, sir. Good night.
Yeah.